Welcome to the section of this course regarding calculus. Today I will be speaking about derivative of inverse trigonometric functions and formulas, how to derive inverse trigonometric functions and its applications by giving some examples of trigonometric functions. Okay, now we have some formulas. Okay, so say for example, number one, we have if y equals to sine inverse x, okay, then dy by dx is 1 upon square root of 1 minus x square. And again you have to differentiate x here with respect to x. Okay, so dy dx of x is 1, that's why I am not keeping anything. Okay, but in some textbook or in some author or some people, what they do is this, what we can say is if y equals to sine inverse of u, another form is dy by say dx, okay, is same as 1 upon square root of 1 minus u square into this with respect this d by dx of u, meaning you have to differentiate with respect to x, whatever the function you have. Okay, this is same as this. Okay, some people write this way, but these are equivalently one and same. Okay, but for this also the domain of x is domain of x belongs to closed interval -1 to 1, but we will not discuss details about the domain and range, codomain, etc. in this section. For details of domain and codomain, range, another video I will make it. Okay, regarding for today, we'll discuss mainly on its derivatives. Okay, so I will write this way, simple. Now first I will prove how this come. Okay, how if y equals sine inverse x, how come dy by dx is this. Okay, if you know sine inverse, then you can find all trigonometric functions. Okay, so first of all I will write down those formulas. If y equals to, say, if y is dy, you can say dx of sine inverse x is 1 upon square root of 1 minus x square. Okay, you can say in 1. Number 2, d by dx of cos x. Please be careful over here. Again, you have to differentiate this with respect to x. For example, if I have d by dx of sine inverse 2x, okay, is 1 upon square root of 1 minus 2x the whole square. Again, 2x you have to differentiate with respect to x. Okay, now if it is cos x, then minus comes 1 upon square root of 1 minus x square. Okay, 3, d by dx of tan inverse x is 1 upon 1 plus x square. Again here, this x belongs to real number, any real number. Okay, tan and cot x belongs to, but we will not discuss more details about domains. Number 4, d by dx of cot inverse x. Cot inverse x is minus 1 upon 1 plus x square. And 5, d by dx of sec inverse x is 1 upon x into square root of x square minus 1. Here in some you can put, according to domain, you can put mod of x. Okay, here x belongs to all real number excluding 1 and minus 1. Okay, because if you 1 square is also same 1 and minus 1 whole square is also same 1, so all the real number x belongs to all real number excluding minus 1 and 1. Okay, so we will not write we will not discuss much detail about it. 6 dy dx of cosec inverse x is minus 1 upon x into x square minus 1. Okay. Now this is the formula we have. Accordingly, we will solve most of the trigonometric functions for inverse derivative. Okay. Now how to prove this? I will prove this. Rest of them are all same. Okay. Now in order to prove this, now if this, then you can say prove that this. Okay. Now we have to prove this. Since y equals to sine inverse x, okay, it implies, or you can say if and only if, then sine of y equals to x. Are you agree? Because sine inverse x, this is sine inverse x. Sine inverse x, if you cross over there, if you cross multiply, it will be sine y into x, and this is also same as this. Okay, these are if and only if, one and equivalent. Okay. Now from here, if I differentiating with respect to x, okay, we have, if I differentiate here, be careful, I am differentiating with respect to what? With respect to x in this equation. Okay, in this equation, now differentiation of sine is what? Cos. Okay, cos of y, but here I am differentiating with respect to x. So what will be? Again this y, I have to differentiate what with respect to x, dy dx of this y. Okay, don't forget to write dy, because if it is sine x, then it will be only cos x. Okay, since it is y, then the differentiation of sine y is cos y into dy dx of x. If it is, for example, if it is y equals to sine x, then dy by dx will be differentiation of sine x is what? Cos x into dy dx of x. Okay, dy dx of x is 1, so we don't have to write this. Therefore, differentiation of, if y equals to sine x, differentiation of sine x is only cos x. Okay, but here we have sine y. Okay, therefore we have to write this is equals to, on the right hand side we have x. Okay, dy dx of x is what? 1. Okay, therefore what is dy by dx? Okay, therefore dy by dx is, if I can send over here, so 1 upon cos of y. Look at here. Okay, if x is this, okay, if we have sine square y plus cos square y equals to 1. This is the identity we have. Okay, now from here, if you want to find cos y, okay, if you want to, therefore cos square y equals to 1 minus sine square y. If I am sending that side, this is the identity we have. Therefore cos y, if I want to find cos y, then we have to take square root on both sides. Taking square root on both sides, cos square root and square gets cancelled, we have cos y, and we have 1 minus sine square y. Okay, look at here, what is y? Okay, y is our x. Okay, therefore this is 1 minus x square. Here 1 minus x square. Okay, therefore this is same as cos y is same as this is our cos y. Okay, square root of 1 minus x square. Okay, therefore this is this. Okay, now if y equals to sine inverse x, then dy by dx is 1 upon square root of 1 minus x square. Okay, this I have proof. Okay, this is proven. Similarly here also, you take y equals to cos inverse x, differentiate this using this property. This is what this is. Identities, you will get it. Even 10 also, you can bring either sine or cos, or you can use the relation of we have what 1 plus 10 square theta equals to sec square theta. By using this formula, you can prove this too. This is we have 1 plus sec square theta, or you can bring either sine or cos. If you are finding difficulties, you can bring everything into sine and cos. Okay, so you can prove all this. Let's take some examples. Some examples of inverse trigonometric functions. Now let's take some example for inverse trigonometric functions. We have seven examples. From this, we'll have some ideas how to solve the inverse trigonometric functions of trigonometric functions. Okay. Now, mostly inverse trigonometric functions you can see from here. From here, you can see by formulas. This one. Let's see. Okay. Let's see all. Okay. One by one. Let's solve. Question 1 is if y equals to e raised to sine inverse 3x. Okay. Now here also what you can do, you can solve with the help of substitutions. Okay. By substituting u equals to this whole term, and then you can find dy by dx is you can find. I'll solve 2 ways. Okay, first 4 questions, rest of them I will solve shortcut. Okay, let u equals to sine inverse 3x. Okay, then from here I can find du by dx. Differentiation of u with respect to x is what? Remember, sine inverse x differentiation is 1 upon square root of 1 minus x square. Our x is what? 3x. Okay. Here 1 minus square root of 1 upon square root of 1 minus x square into. Okay. Be careful over here. Be careful over here. Here you cannot stop over here, because if it is x, you can stop over here by putting 1 upon 1 minus x square. Since 3x is there, you have to differentiate 3x with respect to x again. Okay, so d by dx of 3x you have to write again. Now d by dx of 3x is what? 3 upon square root of 1 minus 3 is a 9 x square. I have du by dx. Okay, now this y become, what is y? Y is e become, therefore y become e raised to what? U. Okay, from here I can find dy by du. Differentiation with respect to u is e raised to u into du by du is 1. Okay, therefore our aim is to find, what is that? Our aim is to find dy by dx. Our aim is to find dy by dx. Okay. Now here with the help of parameter u, I already substituted u. So dy upon dx is same as dy upon du with respect to u parameter, which I already defined, is same as dx upon du. Or you can write like this: dy upon du into du upon dx. You can write like this. Okay, you can, it's up to you here, because du gets cancelled and it's same as dy by dx. Okay, it's better to write like this. Okay, dy by dx is this. This is same as what? Your dy by dx. Okay, so what is our dy by du is what? Dy by du is e raised to u. Okay, here e raised to u. Okay, and du by dx is here. We are here 3 upon square root of 1 minus 9x square. Here, okay. Again, you come back. What is substitute? Okay. What is u? U is, you can say u is what? Sine of inverse 3x into square root of into, okay, 3 upon square root of 1 minus 9x square. Okay. What I'm doing is I am finding by substituting this u, I am finding du by dx. Okay, du by dx is same as this we got it, and you substitute what is u, this become e raised to u. Okay, and find dy by du is this, or you can keep, or you can write like this. E again, you substitute e raised to, what is u? Sine inverse 3x. You can keep like this. Okay, here dy by dx is same as dy by du into du by dx. Okay, so by you can keep like this, or by directly what you can do is, since directly from here, okay, what you can do is this is e. Okay, e raised to something. Okay, differentiation of e raised to something is e raised to something. Okay, here if I have to find directly from here, okay, let's remove all this. Okay, now check here, dy dx of e raised to something is e raised to something. Okay, into differentiation of this with respect to x. Okay, differentiation of this with respect to x is sine inverse x is 1 upon 1 minus 9x square into dy dx of 3x is what? 3. Okay, so directly instead of all this, okay, by substituting you can find directly from here to here. Okay, now next sum is y equals to sine of, okay, sine of 2 into sine inverse x. This is the angle for first sine one. Okay, y equals to sine of this is angle for this sine. Okay, so let's find its derivative. Question number 2, y equals to sine of 2 sine inverse x. Okay, this is the angle for this first sine one. Okay, now again, and this 2 is constant. Okay, remember, so we will not substitute anything. Okay, we will solve directly. Instead of, we can substitute by solving this, substitute by u. Again, you find du by dy by du. Again, du by dx, and then multiply, divide, you'll get dy by dx. So it's one in same. Okay, so it's better to solve directly. So to find dy by dx, so therefore, say differentiating with respect to x, we have dy by dx is equals to, differentiation of sine is what? Cos. We have cos of, consider this is some angle, or cos of that angle, so you have to keep as it is 2 of sine inverse x. Again, you have to differentiate this with respect to x. Okay, this with respect to x is what? 2 is constant, and differentiation of sine inverse x is 1 upon square root of 1 minus x square. Okay, into dy by dx of x is 1. Here is over. Okay, let me repeat again. So y is given, y equals to sine inverse this. You consider this is some theta. Okay, so differentiating with respect to x is differentiation become a sine become a cos. Consider, bring this whole down over here. Okay, again differentiate this with respect to x. Okay, if I differentiate this with respect to x, since 2 is constant, I am writing over here sine inverse x is 1 upon 1 minus x square, and dy by dx of x is what? 1. Okay, this is the required answer. Okay, now question 3, we have y equals to tan inverse x by a. Now differentiating with respect to x, we have dy by dx equals to tan inverse x is what? 1 upon 1 plus x square. Okay, here we have 1 upon 1 plus x square. Instead of x, what we have is x upon a. So instead of x, I have x upon a, the whole square into d by dx of x by a. Okay, it's same as if I square, okay, it will be x square plus a square. Here I have 1. So if I take LCM, this a square will be here. Okay, here it will be a square plus x square, and this a square I can send up. Okay, I can send up here a square. How come from here to here? Here give x square here also, x square here also. It become 1 plus x square upon a square. If I take LCM, 1 into a square is a square plus x square. This a square I am sending here. Okay, here I am having. Okay, now d by dx of x by a. Okay, so will be 1 by a. Why 1 by a is constant? D by dx of x is 1. So you can keep like this, or you can cancel. If I cancel this, a cancel here, you can keep like this. Okay, this is the answer for question number 3. Okay. Now question 4. If y equals to log of sine inverse 2x, okay, y equals to log of sine inverse 2x. Okay, here you know, if y is equals to log of something, then differentiation that is log. If y equals to log x, okay, then dy by dx is what? 1 by x. Okay, here therefore dy upon dx is 1 upon whatever you have. Okay, log of something. Okay, this something will be in down. Okay, here sine inverse 2x. Again, you have to differentiate this with respect to x. Okay, dy dx of sine inverse 2x. Okay, here 1, you can keep 2x like this angle, 1 by sine inverse 2x into difference. Sine inverse 2x is what? 1 upon square root of 1 minus 2x the whole square. Okay, again d by dx of 2x is what? 2. Okay, you can keep like this. Now next question is 5. Y equals to square root of tan inverse x by 3. Question 5. Y equals to square root of tan inverse x upon 3. This square root is what? Square root is x raised to square root. Okay, or you can say x square root is same as x raised to half. Okay, cube root, it means square root of x is what? X raised to half. This is same as this. Cube root of x is what? X raised to 1 by 3. Okay, if you like this also same, this also same. Okay, so I will write x tan inverse x by 3 square root as, I can write like this, tan inverse x by 3 raised to 1 by 2. Why? Because I am going to use d by dx of x raised to n. Okay, x raised to n is n into x raised to n minus 1. I am going to use that. That's why I am bringing this square root as a 1 by 2. Okay, therefore differentiating with respect to x, we have dy by dx equals to something raised to n, or you can say x raised to n. Okay, x raised to n is n into x raised to n minus 1. By applying dy dx of x raised to n is what? N into x raised to n minus 1. Okay, here I will have half, okay, tan inverse x by 3 raised to half minus n minus 1. Okay, we have half minus 1 into, okay, into what? D by dx of tan inverse x by 3. Okay. D by dx of tan inverse is what? 1 upon 1 plus x square. What is our x? X is x by 3. Okay. Here x by 3, the whole square into, okay, be careful here, into you have to differentiate x by 3 with respect to x. Okay. D by dx of x by 3 is what? I can take 1 by 3 common outside, since this constant. D by dx of x is 1, therefore it is 1 by 3. So into 1 by 3 will come. Why? Because I am differentiating x by 3 again with respect to x. This is same as 1 by 3, and this I can multiply is 2 into 3, 6 tan inverse x by 3. 1 minus half is minus half, 1 upon here 3 x square upon 3 is a 9. Okay, here if I take LCM, it will be 9 plus x square upon 3 is a that 3 I can 9 I can bring over here. Okay, or you can cancel 3 to the 6, the same as 3 to the 6, 3 to the 9, 3 to the 6, 3 to the 9. Here 3 by 2 tan inverse x by 3 raised to minus half into 1 upon 9 plus x square. This is the required answer for 5. Okay. Now 6. Okay. 6 is y equals to sec inverse x cube. Okay. So you have to apply the formula for sec inverse x. Okay, y equals sec inverse x. So 6 is y equals to sec inverse x cube. Okay, remember d by dx of what? Sec inverse x is 1 upon x or mod of x, x square root of x square minus 1. This is a formula. Okay, differentiation of d by dx of this is equals to this. This instead of x, what we have is x cube. Okay, now d by dx of sec inverse x is, we know by formula, 1 upon mod of x or x according to the domain of x. Domain of x is what? Here domain of x belongs to in real number excluding minus 1 and 1. Okay, but in details will not go. Now this formula we have to apply, 1 upon x into square root of x square minus 1. Okay, now therefore differentiating dy upon dx is equals to 1 upon, okay, here you consider instead of x we have x cube square root of x cube whole square minus 1 into d by dx of x cube. Just I am applying this formula. Okay, again here d by dx of x is 1, therefore they have not written anything, so here it is x cube we have to write. Okay, here d by dx of x cube is 3x square upon x cube square root of 3 to the 6, x is 6 minus 1. You can send x cube inside square root inside, or you can keep as it is, or you can cancel over here. Here what we have 3 upon, if x square and x cube gets cancelled, x raised to 6 minus 1. This is the required answer for 6. Okay. Now question 7. Y equals to, it is given y equals to cos inverse twice x minus 4. Okay, here we have cos inverse twice x minus 4. Remember d by dx of, remember d by dx of cos inverse x is what? 1 upon square root of minus 1 upon square root of 1 minus x square. Okay, so differentiating with respect to x, remember dy dx of cos inverse x is, we have minus 1 upon square root of 1 minus x square. Okay, applying this formula, dy upon dx I will be getting is minus 1 upon square root of 1 minus x square. My x is this. Here I have twice x minus 4 whole square into, okay, dy dx of this is what? Dy dx of twice x is 2 into minus differentiation constant is 0. Okay, so I have only this. So this will be minus 2 over here. Minus 1 into 2 is minus 2. Square root of 1 minus, you can expand this. Okay, here a minus b the whole formula. Here a square means twice x the whole square minus twice a b plus b square. Okay, you can keep here like this, but let's expand some other terms also. Here we have square root of 1 minus, here 2 to the 4. Okay, here 4x square minus 4 4 the 16, 16x here. Okay, 4 to the 8, 8 to the 16, here also 16. Okay, you can keep like this, or you can send minus inside. Okay, thank you so much.